LLM cost optimization got real for us on a Friday deploy. A coding agent spent $312 trying to fix one flaky integration test. Not a big cloud bill in the abstract. One ticket. The loop kept asking a strong model to patch, run tests, read the same stack trace, and patch again. Attempt 3 and Attempt 9 were basically twins. The cap saved us from worse damage, but it did not make the loop smart. The missing part was a controller asking before each action, is this next spend likely to buy progress? A hard ceiling is necessary, but it is not a strategy. It says when the wallet is empty. It does not say whether the next model call deserves to happen. Sheep-only routing fails because extraction and judgment are different jobs. A small model can pull fields from a log, but may miss that the proposed fix violates an invariant. Strong-only routing fails in the other direction. You pay premium prices for chores, formatting, deduping, summarizing, retrying known dead ends. The deeper problem is that agent loops are sequential investments. Every iteration should answer two questions. Did quality improve? And was that improvement worth the cost? The pattern is a budget controller. It sits beside the task state and decides continue, replan, or stop. My opinionated default is simple. Use a cheap model for drafts, extraction, classification, and candidate generation. Use a stronger model for verdicts, conflict resolution, safety checks, and final approval. After each iteration, update quality score, cost spent, and the last failure signature. If progress is healthy, continue. If the same failure happens twice, stop spending on the same plan and replan. If required quality is met, stop. If improvements are below a minimum for consecutive rounds, stop, because the loop has hit diminishing returns. Mechanically, keep a small budget state object. It should include token budget, tool budget, repair budget, subagent budget, current quality score, required quality, total spent, and last failure signature. Add a model escalation table. Cheap draft for extraction, summarization, and proposed edits. Medium model for uncertain routing. Strong verdict for judging correctness or approving release. Then write the policy. If quality score is greater than or equal to required quality, stop. If same failure count reaches 2, replan. If remaining budget cannot fund the minimum useful next action, stop, with a partial result. Otherwise, estimate the next action cost, estimate expected quality gain, and continue only when progress per cost is still credible. Picture a coding agent fixing a failing checkout test. Iteration 1 uses a cheap model to extract the error, changed files, and likely subsystem. Cost is tiny. A stronger model judges the proposed repair plan because that decision can break production. The agent patches, runs tests, and updates quality from 0.48 to 0.69. Good progress. Iteration 2 improves to 0.78. Iteration 3 hits the same database timeout as before. Iteration 4 hits it again with a nearly identical stack trace. The controller does not buy a fifth patch. It replans. Maybe the fixture is wrong, not the code. When tests pass and review score clears 0.82, it stops. This pattern is not magic. The hardest part is quality scoring. If the score is vague, the controller will optimize nonsense. Use task-specific signals. Tests passed, citations verified, schema compliance, reviewer rubric, production diff size. Cheap models can also hide risk by producing confident but incomplete summaries, so sample raw evidence before trusting the draft path. Subagents are another leak. A subagent should not exist because the main agent feels confused. It needs a bounded deliverable, a cost limit, and a stop condition. Finally, do not make the controller a giant planning brain. Keep it boring, inspectable, and easy to override. This builds on hard budgets, but changes the question. Episode 7 was about ceilings. Never exceed the envelope. This pattern is about marginal value. Should we buy the next step at all? It connects directly to verification, because your progress signal comes from tests, judges, rubrics, or external checks. It also connects to orchestration. Once you run multiple agents, the cheapest savings often come from not launching them. A research subagent, browser worker, or code reviewer should receive a bounded question, not an open invitation. At fleet scale, this controller becomes spend intelligence, many small decisions that prevent runaway loops. Take one automation you already run, not your hardest one. Add a budget state file with token budget, tool budget, repair budget, subagent budget, quality score, and required quality. Add one line of logging after every iteration. Cost, quality before, quality after, decision. Set stop on diminishing returns to minimum improvement 0.02 and consecutive limit 2. Then add the repeated failure rule. Same failure twice means replan, not retry. Finally, write one cost-aware subagent question. It must name the deliverable, maximum cost, evidence required, and stop condition. 3 beats to keep. First, cost optimization is not only cheaper models, it is routing by difficulty. Cheap draft, strong verdict. Second, every loop iteration needs progress per cost, or you are just hoping the next call is different. Third, repeated failure and diminishing returns are stop signals. Same failure twice means replan. Required quality met means stop. Tiny improvement twice in a row means stop. That is how you turn a budget from a panic button into a controller. New loop engineering episode daily on this channel, moving from foundations to fleet scale patterns that finish, verify, and stop.